of compounds of the alkaline earth metals, oxides and hydroxides. The BeO is essentially covalent in nature, while oxides of other elements are ionic in nature. These oxides are very stable to heat. BeO is amphoteric. All these oxides except BeO are basic in nature and react with water to form sparingly soluble hydroxides. MO plus H2O gives MOH2. The solubility, thermal stability, and the basic character of these hydroxides increase with increasing atomic number from MgOH2 to BaOH twice. The alkaline earth metal hydroxide are, however, less basic and less stable than alkali metal hydroxides. Beryllium hydroxide is amphoteric in nature as it reacts with acid and alkali both. BeOH twice plus 2OH minus gives complex BeOH 4,2 negative, that is berylate ion. Also, BeOH twice plus 2HCl plus 2H2O gives complex BeOH4 Cl2. Halides. Except for beryllium halides, all the other halides of alkaline earth metals are ionic in nature. Beryllium halides are essentially covalent and soluble in organic solvents. The tendency to form halide hydrates gradually decreases down the group. The dehydration of hydrate chlorides, bromides, and iodides of Ca, Sr, and Ba can be achieved on heating. However, the corresponding hydrate halides of Be and Mg on heating suffer hydrolysis. The fluorides are relatively less soluble than the chloride owing to their high lattice energies. In the vapor phase, BeCl2 tends to form a chloro-bridge dimer which dissociates into the liner monomer at high temperature of the order 1200 Kelvin. The structure of a typical BeCl2 molecule is shown below. Salts of oxoacids can be divided in three parts as salts of carbonate, salts of nitrate, salts of sulphates.
Click on the following button to know more.
Salts of carbonates. Carbonates of alkaline earth metals are insoluble in water. The solubility of carbonates in water decreases as the atomic number of the metal ion increases. All the carbonates decompose on heating to give carbon dioxide and the oxide. Beryllium carbonate is unstable and can be kept only in the atmosphere of CO2. The thermal stability increases with increasing cationic size. Salts of sulphates. The sulphates of the alkaline earth metals are all white solids and stable to heat. BeSO4 and MgSO4 are readily soluble in water. The solubility decreases from CaSO4 to BaSO4. The greater hydration enthalpies of Be2 positive and Mg2 positive ions overcome the lattice enthalpy factor and therefore their sulfates are soluble in water. Salts of nitrates. The nitrates are made by dissolution of the carbonates in dilute nitric acid. Magnesium nitrate crystallizes with 6 molecules of water, whereas barium nitrate crystallizes as the anhydrous salt. All of these metal nitrates decompose on heating to give the oxide like lithium nitrate. According to the reaction, 2MnO3 twice on heating gives 2MO plus 4NO2 plus O2, where M can be Be, Mg, Ca, Sr, Ba. Question: why does the solubility of alkaline earth metal hydroxide in water increase down the group? Solution: among alkaline earth metal hydroxides, the anion being common to the cationic radius will influence the lattice enthalpy. Since lattice enthalpy decreases much more than the hydration enthalpy with increasing ionic size, the solubility increases as we go down the group. Question: why does the solubility of alkaline earth metal carbonates and sulphates in water decrease down the group? Solution: the size of anions being much larger as compared to cations, the lattice enthalpy will remain
almost constant within a particular group.
Since the hydration enthalpies decrease down the group, solubility will decrease as found for alkaline earth metal carbonates and sulphates.